Hi everyone, welcome to my video report of Lab 5 in Physics 2 class at Georgia Tech. In this lab, we focus on the concepts of magnetic field and the magnetic force. The key component we utilize in this lab is the Faraday's law. In the experiment we completed, we dropped a powerful magnet straight down through a conductive tube of aluminum foil. We need to find the time it takes the magnet to fall through the tube, but both real-world measurements and computations through code simulation. In our computational model, we approximate the aluminum tube by decomposing it into multiple rings stacked up across the length of the tube. If you're interested, feel free to click on the link down below to my code implementation and follow along my explanation. With the magnetic moment value taken from that tree, we are able to compute the rate of change in magnetic flux through each ring when the magnet is falling through the tube. Next, we use the Faraday's law, which is stated on the right, and we can compute the voltage around each ring and also the current induced in each ring. Next, we apply Biot-Savart's law, which is stated on the bottom right corner, to compute the magnetic force on each ring by the falling magnet. Then with Newton's third law, we get the force with exactly the same magnitude, which is the force on the falling magnet by the rings or the entire tube. With the force by the tube combined with the gravitational force of the magnet, we can compute the net force in the vertical direction. And applying Newton's second law, we are able to compute and simulate the position and velocity values throughout the time when the magnet falls through the tube. We can further analyze and explain the simulation results. We can notice there are red and blue rings representing the direction of the current on the tube. By finding that the change of magnetic field is positive in downward direction, and applying the right-hand rule, we know the red ring represents counterclockwise and the blue represents clockwise current direction. If we flip the magnet, the only thing that will change is the direction of the current on the tube, because the direction of change in magnetic field will be exactly the opposite. The computed time it takes the magnet to fall through is not 1.999 seconds, whereas the average of measured time is 1.36 seconds. So the time from simulation is larger. There are several possible error sources. One of them is that I directly use the magnetic moment for the magnet from lab 3. But this value is retrieved by lab experimentation, so there might be some imprecision around this value. Also, it should be more precise to measure the exact time it takes the magnet to fall through. In the velocity versus time plot, we can observe that the velocity greatly increases and then suddenly decreases a little bit at the beginning. This happens when the magnet just enters the tube. At this point, the magnetic force is larger compared with the gravitational force, so the magnet slows down a little bit. Then in the middle of the falling, the velocity is not varying because the net force on the magnet is approximately zero, where the force by the tube balances the gravitational force on the magnet. There are also some additional questions. What if the resistivity of the conductor reduced as close as possible to zero, and how the dynamics change? With less resistivity, the conductor can have a larger current. That will result in a larger magnetic force on the magnet by the conductor. Equivalently, to balance with the gravitational force, we only require a smaller velocity of the magnet as opposed to what we had before. Therefore, the falling magnet will fall through the tube with smaller velocity and it takes longer time. What if holes or slots were cut into the tube, and how would this affect the currents? If there are holes or slots, then rings in our model are no longer complete, and thus the current values will decrease. As a result, the magnetic force on the magnet will decrease, and with a similar reasoning to the previous question, the magnet can pass through the tube with shorter time. This is the end of my video report. Thank you for watching.